This video is on the key features of quadratic functions. So first, we're going to look at the domain. So my quadratic has arrows on the end. And this arrow means that the graph extends infinitely up and to the left. And this arrow means that the graph extends infinitely up and to the right. So my domain is going to be all real numbers. And what this means is that any x value that I can think of, I can find the corresponding y value. So if I said, what if x was 1? My y value would be -1. What if x is 0? My y value would be 4. What if x is -2? My y value would be somewhere up here, maybe 13, 14, something like that. If I can imagine an x value of -10, I would be all the way up there. But I know that my graph would eventually make it because my domain is all real numbers. Those arrows on the end mean that it gets wider and taller as we go. Now my range, I can't just pick any y value and know that there's going to be a corresponding x value. If I say, what is the x value when y is -10? Well, there isn't one. What is the x value when y is -8? Again, there isn't one. My graph doesn't go there. My graph is from -5 and up. So my graph only is above -5 and including -5. For zeros, I need to know the x-intercept. So I'm looking at where the graph crosses the x-axis. And I see I have 2 times where it crosses the x-axis. I don't know exactly where they are because I don't have the equation, but I can estimate that these are maybe, it's a little bit before 1. So maybe like 0.8 and maybe a little after 5. So maybe 5.2. Okay, y-intercept, I'm looking for where we cross the y-axis, which is right here. So that's at 4. So that y-intercept would be 0, 4. Okay, that point what we were talking about with the range, that the lowest that we go is -5, that's because we have a minimum value. The minimum is at that vertex. So the point where I have that minimum value is 3, -5. And the axis of symmetry is referring to if I were to draw a line down the middle of the graph where I would be symmetric. So that means that if I fold my graph right in half, I would do that right here, and I would see that this is the middle of my graph. So that is going through a x value of 3. So we'll say that the axis of symmetry is x equals 3. Okay, so this has arrows as well. They're going down and out to the left and down and out to the right. So my domain remains all real numbers. My range this time, the highest that I go is -6, and I'm going below that. So I'm going below -6, including -6. Okay, my zeros are the x-intercepts. So I'm looking at where it crosses the x-axis. I don't. So the answer here would be none. We have to have a y-intercept, always, always, always. And I see it's right here at -7. So that's 0, -7. This would be a maximum because it's the highest point on the graph. The maximum is the same thing as the vertex here. So I'm looking at what that highest point is right there. So that would be -2, -6. And my axis of symmetry goes straight down through the middle of the graph. It's where I would divide my graph right down the middle in half. And that goes through an x value of -2. Okay, again, I have those arrows that are extending up and to the left and up and to the right forever and ever and ever. So my domain would be all real numbers. My range, the lowest y value that I go is 0, and I'm above that. So y is greater than or equal to 0. I actually only have one x-intercept, 1, 0 here. It just touches at -1. So there's my 0. My y-intercept right there, where I cross the y-axis, that's 0, 1. That blue dot would be a minimum because that's the lowest point on the graph. That's the vertex. It's the same as the 0 in this case. And then my axis of symmetry is that straight line that goes right down the middle of my graph, cutting my graph perfectly in half. So right there, that goes through an x value of -1. Okay, last example. Again, just like all the other ones, I have those arrows, so my domain is all real numbers. My range, the highest value that I get to is 1, 2, 3. I'm going below that. The graph is below 3. So y is less than or equal to 3. I actually come up and touch 3, and then I'm below. Again, I'm going to have to estimate my x-intercepts here. It looks slightly past 0 and right before 4. So slightly past 0, I might say 0.2. And it's almost at 4, so maybe like 3.8. Okay, my y-intercept is right there where I cross my y-axis in orange. So that's 0, -1. That green mark that I made on the graph is my maximum. It's the highest point on the graph. That's at 2, 3. So that's a maximum, sorry, that's the vertex. And then my axis of symmetry is going to go straight down the middle of my graph, cutting my graph exactly in half. And that goes through the x value of 2. 1, 2, right here. So that's x equals 2. So if you're starting to see a little bit of a pattern, you are correct. The number that we use in the range is the y value of the vertex. The number that we use for the axis of symmetry is the x value of the vertex. So you should see that every single time. Sometimes the 0 ends up being the vertex, but not always. That was only in one example.